Welcome to calculus class. I have another free response question. Given the function f of x equals 4x to the third minus 2x, find critical point or points, find local absolute minima and maxima, and find inflection point and concavity. Let's do that. Okay, so first, if you have the function, given the function f of x equals 4x to the third minus 2x. If you want to find critical point, this is your condition always. You're going to take the derivative and equal it to 0. Let's do that. So the derivative of the function f of x equals, you drop 3 to be 12. 3 times 4 is 12. X to the second minus derivative of 2x is 2. Then equal it to 0. When you equal this equation to 0, then 12x squared equals plus 2. Then divide by 12x squared equals 2 over 12. Or it's 1 over 6. So x could be positive or negative square root of 1/6. So we have critical points when x is the square root of 1 over 6 and negative 1 over square root of 6. We have x already. We need to find y. To find y, just plug it in, square root of 1 over 6 in here to find y, to find its y. So let's do that here. So 4 times, instead of x, replace square root of 1/6 to the third minus 2 times square root of 1 over 6. Okay. So this one, square root of 1 over 6 times square root of 1 over 6 times square root of 1 over 6. Yeah, let's see here. 1 over 6, square root of 1 over 6, square root of 1 over 6. These together will come up with 1 over 6. No radical, just cancel radical. So it's just 1 over x. 1 over x. 1 over x in here. 1 over x. 1 over 6. And square root of 1 over 6 left. Times 4. Minus 2 square root of 1/6. Then divide by 2, then it's 2/3. This is 2/3 square root of 1/6 minus 2 square root of 1/6. Then if you subtract 2/3 minus 2/6 equals negative 1 1/3 square root of 1/6, which is negative 4 over 3. So y here is negative 4 over 3 square root of 1/6. That's y. It's y. So the first critical point will be square root of 1 over 6 and negative 4/3 square root of 1/6. And the second critical point, which is negative square root of 3. We replace negative here. If we replace negative, then this will be negative. Negative 1/6 to the third, and we have negative will be negative. It's the same, but it will be negative. So this is negative. And here is, if you replace negative in here, negative 1 square root of 6. Okay, negative times negative 2 is going to be positive. So this is going to be negative, and this is going to be positive in here. Then 2 and 2/3 2 and 2/3, which is 7/3 square root of 1/6. Y is 7/3 square root of 1/6. So here is our critical point, the second one, which is square root of 1/6 and positive 7/3 square root of 1/6. This is our response to critical points. We need to find absolute and minima, maxima. So which one has the minima? Which one has the maxima here? The minimum y is negative 4/3, and the maximum y is 7/3. So minima, maxima. Now, in order to find critical points and concavity, we need to continue. If we want to come to inflection point and concavity, we have to find the second derivative of the function. So this the first derivative is 12x squared minus 2, and when you find the second, drop 2 to be 24x. So the second derivative, okay, let's change the color here. The second derivative, which is, you drop 2 to be 24x. That's all. 24x. Then you equal it to 0. That's you. If you want to find critical points, is going to be 24x equals 0. Then x equals 0. To find y, just plug it in into the original function. If you plug it in, x equals 0 in here, will be 4, 0 to the third, which is 0, minus 2 times 0, which is 0. 0 minus 0 is 0. So y is 0. Y equals 0. So the critical point in here will be 0 and 0 as critical point. To not like, look, we are blind, we cannot see the function. Not to be blind, we could graph it to investigate our answers here. And I graph it here in this MOS. I have like two different systems in my laptop. One is this MOS, which is perfect. They don't allow it in AP, but the second one, which is I-84 calculator, Texas I-84, TI-84 plus or TI-85, depends what you have. So I graph it here in this MOS. This is the function for x to the third minus 2x. And as you see, we have here two different points. We call this critical points in here. Yeah. This is negative square root of 1/6. And this is positive square root of 1/6. Our y here is maximum, which is 0.54. This is the maximum point. Local maximum, because we still have maxima go up there to infinity. And here is local minimum, which is the minimum point that we have the slope change from positive to negative in here. And also the critical point, it will be between the change between the two critical points in here, which is the inflection point. The inflection point at 0 and 0. Just to make sure that we are right. Inflection point and concavity in here. Concave up is like fish trying to jump from the ocean to the sky. Okay, that's concave up. It's between 0 and 0.707 in here. And concave down, you dive like you do diving. It's between negative it's between negative 0.7, which is negative square if you equal it to 0. That's negative 0.7 and 0, concave down. So we finish the our assignment. We investigated critical point, and we did local absolute minima and maxima, and we did inflection point, and you mentioned the period of concavity, from where to where and from where to where. You mentioned the period between what and what. Thank you so much. I wish you got it. If you have any question, mention it in your comment. Thank you.